Hi, welcome back to my Python tutorial. At the end of our last episode, we had installed Visual Studio Code and Jupyter Notebooks. So this should look vaguely familiar to you. I've just opened a folder and created a file ending in IPYNB. So you can just go new file, test.ipynb. Visual Studio Code will know that that's a notebook. We'll do that survey later. And it'll let you do some cool stuff, like print hello. You click play, and you see your output right here. Now, the fact that we're running on our local computer means that we can do some cool stuff, like write a file, which we couldn't do in ProgramIs. I don't think we could. So we define some data. We open a file for output. So I've called it file out. That's not what tells the computer its output. This could be called anything. We're opening the file called test.txt, and we're opening it in write mode. There are some things you can put in here. You can put read mode, put read binary, write binary, and there's other modes as well. But for now, we're opening it in write mode so that we can write some data to it. So what we expect to happen is we expect to see a file created here called test.txt, and we expect to see one line in that file, which will be this. We're closing the file at the end. That just means that any other program on the system can open it, can use it, and it won't be blocked by us. So if I click play, we see this little execution time down here, which is cool. When we're doing bigger things, that's really interesting. And we see test.txt open up here. I can double click, and it opens it up and it shows us what's in there. I can also drag this tab over here to have it sitting there so that we can see what's going on. Just gonna adjust some sizes so that we've got some space. So if we had a list and we wanted to write it to a file, let's see what happens. So we define some data. It's a list with 3 elements in it. Hello, how are you? I'm pretty good. And we're doing the same thing. We're opening a file for writing. And if we do that, we get an error. Because the write function here expects a string, not a list. So last time we used it, we passed in some data. Some data was just a string. This time we're passing in some data, but some data is a list. So really helpful error message here. We get some color too, which helps you read it, shows you exactly what line it's on. Yeah, really useful. So instead of using write, we're going to change, this is the same as above, but we've just changed to write lines. So again, we've got a list with 3 elements. We're opening a file for write. This time we're using write lines, some data, and we're closing the file. Well, it worked. We got our 3 elements written, but you can see here it's just written one element, then exactly the next, then exactly the next. So there's no spaces, there's no new lines. It's a little bit ugly. We could come in here and add spaces, and we would see what we expect, kind of. We could add new lines. So backslash is a special character. It basically says, hey, whatever's coming next is something special. So backslash n is a new line. If you're on Windows, technically it's RN, but weird stuff happens if you use that sometimes. So if you ever see backslash R, backslash N, that's the Windows way of doing it. But it looks like Visual Studio Code is choosing to interpret the other way, the Linux way. So other things that can go here, I think, is backslash T for a tab. And there's all kinds of stuff you can put there. So if you're ever looking for a special character that you don't know how to type in a string, it's entirely possible that you're looking for backslash and then something. But let's go back to this original list that we had. And let's say we do have a list of elements and we want to write them with new lines between them. We don't want them to look ugly like that. And we don't want to go through and actually append a new line to everything in the list. How are we going to do that? So one way we could do it is we have some data. We open our file for writing, and we're just going to say for line in some data. So for each element in the list, I want you to write the line and then write a new line. And that'll work. So here we see, hello, how are you? I'm pretty good. We do have a new line on the end. So we can see there's a blank line down the bottom because after the last line, it still executed this, which is fine. And then we close the file. But there's got to be a better way, right? It can't be the right way to loop through your data and do two things. So instead, Python has this join function. And what the join function does is it joins the elements of a list. And you can see this is kind of weird notation, right? We're not saying join some data and do something. For some reason, we're starting with this string. And I forgot to mention earlier on, it doesn't really matter if you use single quotes or double quotes. They do mean slightly different things, but they're both strings. So we can see here the join has put a space between each element of our list. And that's how it works. Whatever you have in this initial string, even if it's something ridiculous, it will put that between the elements of the list. And that's really useful for us because we wanted new lines between all the elements of our list. So now we go back to our original use case. We say, hey, we have a list. It has 3 elements. We open a file for writing, and we say write lines. Hang on a second, that should be right. Let's come back to that because they'll both work. Write lines. We pass in this new line character and we say join the list with the new line character between each one. And we can see we have that here. And we don't have this spare empty line at the bottom because it only puts it between the elements of the list. So I think if we type write in here, because join returns a string, right? That should work as well. So write lines works if you pass in a string because it just treats it as a list of one element. But just picking up a little bit of an inconsistency in my code there. So then what happens if we want to add something onto this, right? So we have a file that exists and it has some data in it. It might be a log file, right? You're running a long-running process. You want to log to a file so that you can open that file up and see how things are going. Adding to the end of something, as we discussed when we were talking about lists, is called appending. So we open the file in mode A for append, and then we just write again. And we've got write lines here. Could be write lines. Shouldn't matter. We're adding a new line on the end because we know that last time we wrote to it, we didn't have a new line on the end. And then we're going to close it. So when we run this, we see it come up. And we can run this over and over and over again. And each time it'll open up the file. It'll write whatever we pass into the end. And it'll close the file. So here we want to do the exact opposite, right? We've got a file on the disk. We've got a bunch of data in there. We want to read it in and store it in a list. So we open our file in read mode. We say, so this shouldn't be new string. It should actually be a new list, but that's okay. filein.read. Now, filein.read is just going to give us the contents of the file as a string. So the opposite of this join function up here is split. So what split does is it says, hey, take a string. Every time you find a new line or whatever we pass in, could be a space, could be a tab, could be a comma, I want you to split that into separate elements. And we can see here, if we do that and we print out the list, bingo, it's worked. So we can also see that if we don't split it and we just say filein.read, that we'll get one big string, which is fine. Sometimes you want that. And if we use filein.readLines, we get this list, but it's got these new lines on the end of it. Usually, not always, but usually when you're reading in something that's delimited, that has new lines or commas between the elements, you want to strip away that delimiter. So there's various ways to do that. We could do that by itself, but we may as well use the split function because it knows exactly what we want it to do. We want it to split on that delimiter and then strip it out of the element. So that gives us exactly what we want. So here we're just looking at some other ways that you can use data in a file. You don't always want to read everything into one list, right? The data might be different types of things. You may not have enough memory to read it all in at once. So sometimes you actually want to say, open a file, and then for each line in that file, do something. So this is very similar to the syntax we used when we had a list and we wanted to iterate over that list, right? So here we've said, open a file, for each line in that file, print the line. Now, you'll notice we're getting these weird spaces in between our lines. That's because print adds a new line onto the end of whatever it prints, and our lines already have a new line on the end of it. So we're getting these double spaces. There is another way to do this, which is kind of cool. You'll notice here, we're not closing the file at the end. We're saying with open file as file in, do something. Now, Python knows that when it first runs this chunk of code, it needs to store the variable as file in, and that creates a file handle object. That file handle object actually has a property that says, hey, Python, before you destroy me, I want you to do something for me. And in that destructor, it actually asks to close the file itself. You see this a lot with connections to things. It might be a database connection, it might be a connection to a file, where we need to dispose of something correctly. To prevent us from forgetting that, we can use this with block. And the file's automatically closed, and we can still use the data at the end because we've stored it somewhere. So that's really simple file input-output. You'll hear it called file I/O. That's just input-output. A good thing to know about when you're using files is error handling. Because unlike a lot of the things we've been talking about so far, variables in memory that we own, they're part of our program, a file is shared amongst programs on a computer. So if you go to open a file for write, and somebody's already writing to it, then you're going to get an error. So you'll want to know how to handle errors. Also, if you try and open a file that's not there, you're going to get an error as well. So simply, we've seen some errors before. Just going to close down some Chrome tabs. We've seen some errors before. We get a big red thing and it tells us what the error is. And that's fine. If you want the program to stop when you get an error coming through, this can be a perfectly legitimate output if it's you that's running the program. If some user is running the program and they see something like this, they're going to freak out, right? They're not going to know what's happened. They're not going to know how to fix it. So sometimes we want to handle errors. And the way that we handle errors is we use a try except block. So we try some code. If we get an exception, we run the except block. So here we're going to try the same thing. We're going to try to divide 1 by 0. And if we get an error, we can handle it in a way that is friendly. So here we've said, oops, there's an error because division by 0. Now that's a trivial example, but you may actually, if this was user input, there's 0, you may say, please enter another value, 0 is not valid, those kinds of things. You can explain it in a way that the user will understand, or you can handle the error in a way that you want to handle it programmatically. It doesn't have to be feedback to the user. You could actually just say, no, instead divide by 1, whatever you want to do. So similarly, if we try and open a file that doesn't exist, we get this error. Very useful as a programmer, tells you where it is, not so useful as a user. So instead, we can handle the error. Now up here, we've used a generic exception, right? We've said any exception that occurs, exception is just an error, do this thing. You can also handle different types of errors, right? So you might have a file not found error. You may also have, whatever error the OS raises when somebody else is using the file. And you could write different things for each of them. You could process them differently. So here we're going to try and open a file that doesn't exist. And if we get file not found, we're going to do two things. We're not just going to write something that the human can read. We're also going to print the error out, the exception out itself. So here we see, hey, we couldn't find the input file. Please ensure it exists. Great, good thing to say to a user. We also say something below it where if we're talking to that user and we want more information about the error, then we can do that. There's also other things you can do with this exception here. You can print the stack trace. You can do all kinds of things to make it easier to debug. Now, in here, if we do something else, if we say print 1 divided by 0, I think this is actually my next example as well, then it won't raise a file not found error. It will raise our divide by 0 error. So we won't execute this handler. We'll execute this one here. So we see it doesn't write that specific chunk of text that tells the user what's going on. We have a generic error handler. So generally you go from most specific to least specific when you're putting your error handlers in, and it'll try the first one. If it doesn't trigger that, it'll try the next one. And if it doesn't trigger that, it'll try the next one. I'm actually not sure whether it goes in order of specificity or order that you've got them there. So let's find out. Let's do an experiment. So yeah, it just goes in the order that you've got them. It sees an error. It checks the first one. It says, yep, this is an exception. I'll happily use this error handler. So you want to put your things in the order you want them tested, which is usually the order of specificity. And this is just the same example here. So we've covered some file input-output, and we've covered some very basic error handling. The next lesson on the list is classes and objects. So we'll be learning about how to create an object and how to give it properties and how to give it functions and how to use it.